This video covers what is a receiver, or more technically, a long-range receiver. This video does not cover individual receivers and their functionality, nor does it cover the setup and operation. See our product page for specific information on each individual product type. This will help you become accustomed to when to select a receiver, when not to select a receiver, and what are the pros and cons, and within that family, which one a long-range receiver that is smart versus regular. All right, why use a receiver? Well, the main reason is cost. A receiver is simply just a board that has very simple CPUs. It doesn't have any Ethernet connections. It's very, very simple. But what it does have is it has power, outputs, fused connections, and a way to receive data. And in this particular case, we also even have a more advanced receiver with a screen on it. But typically, we'll have something fairly simple. Here we have a long-range regular receiver, and you can see it's a very simple board. And that means low cost compared to a controller that has very complex electronics. So if we look at this CPU, you can see we have two very complex CPUs, and we also have SD card, Wi-Fi, Ethernet, audio, all these connections. So this is a very complex board. So cost is the main reason you use a receiver. The other reasons are distance. Now, as I mentioned, the main wording in receivers is long range. Long range is defined as over 25 feet. Why is that number 25 feet? Well, when we output data to a SPI connection, and that's just simply the data that goes from the board, whether that's a controller or receiver, to the pixel itself, is a very low signal output level. Typically, it is 3.3 volts. That means that as the signal travels across the connection of cable to the pixel, it can become corrupt. This is why we can't run the very long links. Now, that's for the signal. We also have power inside of a SPI cable that has positive, negative, and a data signal. There's also losses that occur inside the cable itself that reduce the amount of power that reaches the pixels. So generally we need power close to the pixel and we need data close to the pixel. Now, if we don't have either of those things, a long-range receiver is perfect for that because, again, it combines this power plus brand new data, which then allows us to go that 25 feet. Now, on a long-range signal, this signal is actually what's called differential, and it's also 12 volts as opposed to 3.3 volts. So imagine a world where you have two people separated by a large distance. One is whispering at 3.3 volts, and the other is using a megaphone at 12 volts. That is exactly what long range is. Ability to send data over very long distances. And additionally, long range uses different protocols that allow it to have extremely reliable connections. Because it is a differential signal, it's able to overcome lots of outside interference like high voltage and such. This protocol originates from the industrial world where reliability is very important. Now, another advantage to long range is typically we see controllers in either 8 or 16 outputs. Well, what happens if you have a prop? Maybe you have some candy canes far away from your regular display, some mini trees or something on the fence or a house outline with some lights around the backside. Well, you don't need all of those outputs. You don't need 16 outputs. Sometimes something as small as 4 outputs will be more than sufficient, and you just need a way of getting that power and the data to that distance further away. So if you have lots of density, that's probably not the best choice here, and we'll talk about that later. All right, so why not to use a receiver? The inverse of what we just talked about. Let's say you're building a megatree and you need 32 or 48 outputs. And let's say that you need 2, 4, 6 power supplies to power all those pixels because you have a very high density. This is typically in things like megatrees or matrix panels where you have lots of outputs and lots of power all in one place. That's where it makes sense to still continue to use a pixel controller with standard outputs on the controller itself. All right. Now, what exactly is the difference between a receiver and a controller? Now, we've already alluded to it. Let's go over that in detail. So the first is, let's look at the way they receive their data. Now, on a controller, we have Ethernet connections. So here they are right here. This is Ethernet. Ethernet runs over a Cat5 style cable, and so that looks like this. You've seen these everywhere. They've got the 8 pins. They've got the jack with the keystone on the back. These are what's used to send data to these controllers. Now, that uses, of course, TCP/IP and a whole different signaling system. Now, long range also is built on the exact same cable. So same exact cable can be used in long range as a controller. Now, it's important to understand that you will see some differences here. A long range and all of our products have red jacks. So you can see that they're red on the inside, as where our controllers have black on the inside. So I'll just show you a few more of these. So red here, you can see red here, and of course red here. Even on the output board of the controller, we'll talk about this later, we have red, and even here we have an AC board. It has red. So what you need to always do is make sure that we're only connecting, even though the physical cables are exactly the same, red to red only. So only devices that are long range should be connected to other long range devices. This, even though it is a Cat5 cable, cannot be plugged into a Ethernet network and thus have an IP address on it. All right. Now, as I mentioned, this type of protocol is different. It's differential, and that means it's more reliable than Ethernet, and it has a higher voltage, so it's able to overcome bad signaling conditions. Let's say you've got your data cable running next to your power cable. That can cause problems with an Ethernet cable, where it may not cause a problem with a 422 connection. Now, in terms of configuration, long range regular, and we will get into this, doesn't require any kind of configuration. There's no IP address or configuration. On a long range smart receiver, we do have a configuration. There's little switches here, but there's no IP address. This is what tells the system how to address the channels. And then in this particular receiver, we have an addressable option for using a screen instead of actual dip switches we change. But they're fairly simple. Now, it's also important to understand a receiver always requires a controller. So in a controller within our system, you would have a CPU like this, and it would output data to this ribbon cable, which would then be received by this port, and then output that data onto these Cat5 red long range jacks. That would then be received at the other end of a Cat5 cable right here. So you always have to have a controller as part of a long-range system. You cannot directly connect a receiver to your regular Ethernet network. You don't configure a receiver directly in the application. You would configure the controller, which then sends data on behalf to the receiver. All right, so that's what a receiver versus controller is. And now let's delve into what is long-range regular versus long-range smart. Let's first start off by talking about what they both have in common. Now, as I mentioned, over here on the right, we have a long-range regular. And what you'll note here is that we only have one jack. There's not multiple jacks here. It's a one jack coming in. Here, we have a long-range smart receiver, and you'll see we have this jack right here, and if you look closely you'll see it says line in, and then you see at the top up here line out, line out. So they all use Cat5 cable to receive their signals. Now the distances from the controller to the receiver can be over 300 feet of cable, and in certain cases, depending upon the quality of your cable, you can even go further distances. So this allows you to have a very good long-distance Cat5 connection with super inexpensive Cat5 cable. One of the many reasons why Cat5 is used. Now, all of our receivers do have status indicators. In this particular case, this one has a status indicator to indicate data flowing to it. And this one also has an indicator to show data is being received. It's almost like being able to listen in and hear the data actually going across the line. And we'll talk about the pairs of wires and how that works. This receiver also has a status indicator to show that the outputs are programmed, because on Long Range Smart, we'll talk about that, it does get programmed. It has to receive some instructions as to tell it what its job is. A long range regular, very simple, doesn't require that kind of programming and thus doesn't have those LEDs. But there are status indicators on all of these. Now, these also all have status indicators for fuse blown. In this particular case, this receiver doesn't have fuses, it has poly fuses. There is a fuse blown indicator so that if the fuse has been tripped, you'll know that. And all of the receivers have that. Now, all of the receivers also have the same limits as to the amount of pixels that can be controlled. Now, we have varying different controllers within the flex system. The flex system is what the CPUs are based on. And that flex system is based on these jacks right here, the ribbon cable connections, which connect to expansion boards. And this is just one. Of course, we have other types of expansion boards, AC, regular SPI, and of course here you see long range. Now, it's important to understand that the CPUs each have differing amounts of outputs. Now, not shown here is an AlphaPix AlphaPix 16 Evolution, which supports 340 pixels per port. So what is a port? Now, a port is one of these. So this is 1 through 16, 17 through 32, 33 through 48. This has 48 ports. An AlphaPix also has 48 ports. Now, the number of pixels that can be sent down this port on each one of those cables depends upon the power of the CPU. The AlphaPix, again, has up to 340 pixels per port. The HolidayPix Pro version 1.2, which is this is a version 2, supports up to 680 pixels per port, so double. And if you have some monster requirements, this supports not only 5 ports, so 80 ports total, or 5 ribbon cables, 80 ports, but also because it has 2 CPUs on it, it supports 1024 pixels per port. What does that mean? What that means is, let's say that we are going to use this controller, an HolidayPix Pro version 2 with this receiver. That means that this specific plug can have 680 pixels hooked up to it. Now, that doesn't include power, that just includes the data. And if you were to use it with this controller, you would have 1024 pixels on the same exact output. Or if you have an AlphaPix, it would be 340 pixels per output. So know that as you go up in CPU from good, better to best here, you are going to obtain additional output. And we'll talk a little bit more about that later. Now, all the receivers have fuse connections. They may be either blade fuses like this, or they may be poly fuses like this, or you can see poly fuses here. All of those receivers have that, and all of them have a power input. So they are designed to output power across this through these fused connections. And again, as we talked about earlier, power and data is what you're trying to put locally at your props. All right, so now let's delve into what's different about regular and smart receivers. Now, first is this is a regular receiver. This is the only receiver at the time of this video that's available. This regular receiver is very, very simple. It simply has an input port that comes from the long range expansion board right here, and it outputs data across 4 individual outputs or connections. You could also call them ports. Now, this board can be used also with AlphaPix or HolidayPix CPUs. Now, it's important to note that the AlphaPix does not work with smart receivers, and we'll talk about that in a moment. All right, now this effectively is nothing more than the ability for you to move 4 SPI outputs away from the controller. So if you think about it, if you have a normal expansion board that has 16 outputs, similar to what you have here, 16 cables, that board is the same thing as this. What we have inside is the same amount of data and output connections. So inside of each one of these jacks is a pair of wires times 4. So there are 8 wires, 4 pairs, 4 pairs times 4, 16. That is your 16 output equivalent of an SPI normal board, like if you had one connected directly to the controller. So what does that mean? Well, that means that if you have this and you have a network connection going between here, a cable, Cat5, to here, you just basically have moved the Cat5 connection to here and outputting your 4 outputs at a remote location. Again, long range. So if you had, let's say, a distributed project where you have a prop over there and a prop over here and they're all spaced out over a large area, this makes more sense than doing 16 individual outputs. Now, this doesn't make sense, of course, if you need 16 outputs at each of those locations. We'll talk about that and where Smart's a better choice for that. Now, also part of the long range regular is it's super simple. I would say, to use a negative term, brain dead. It's just that simple because this is nothing more than just an extension of the controller. So you can put 4 of these on, you're good to go. Now, this has disadvantages. This does not allow any kind of daisy chaining. As I pointed out earlier, we have an input and outputs on Smart, and we'll talk about those. This does not have that. This is a single point. So if we are jumping to a location and we don't intend to then go from that location on to somewhere else, great, perfect solution. The board is cheaper, the installation is simpler, and it's just across the board a better choice. And that's why we have long range regular. Now, that low cost, of course, doesn't allow you to then daisy chain. All right. The other disadvantage here is this does not have a built-in test mode. So there's no built-in test mode with this receiver at the time of this video. So if you want to test your lights, you would need to go back to the controller and do a test mode. You can't do a test mode directly on the receiver. All right. So that explains what a regular is. Now let's talk about Smart. Now, it's important to note that Smart can only be used with a HinksPix Pro CPU. And again, this could be a version 1, 2, which is what we have here, or a version 3. And we've already talked about the pixel count differences, and that's why we have different versions. Long Range Smart is exclusive to the HinksPix system, and it is much more flexible. Again, this is why the AlphaPix system is a more simple, basic system that has less expandability, as where the HinksPix is a very expandable system. All right, so long range Smart always required to use with HinksPix CPU. Now, the first notable difference is we can daisy chain all long range Smart receivers. So we come in, as we mentioned here, we come in with a signal. We could come, for example, from this output, go here, and then let's say that this is 100 feet away from where your controller is that has this long range expansion. And then you have maybe a couple of other props that are near this. A house outline is a fine example. You may come to the side of the house and you need to go around the back of the house. Well, you need to come here, start, and then daisy chain out, go out, and then hit another one of these. So you can go out, in, out, and then back to another in. Now, we also sell that in a 8 output receiver, so you can actually come in and then go out to the next receiver board next to it. So you can buy this setup as a fully assembled system in 4.8. Now, I should also mention here, I am not showing you all of these systems fully assembled. I'm only showing you this particular one here, and we'll talk about that at a later point. All right. Now, because of the additional functionality of the long range and the fact that you can daisy chain them, we have a little bit more complexity as to setup. The first, as I had earlier mentioned, you need to set an address because we can have up to 16 of these long-range 4-output receivers within the context of how many pixels you can output from the CPU. you have to be able to set the address to let it know where it is, because they're all sitting on a line. Think of it as like a party line on a phone. They're all hearing the same data, but they need to be told, you are this number and you are this number. And that is why we have either a dip switch in this particular case, or if you see this board, you'll see that there's a dip switch here. And on this particular board, as you saw below here, it configures via a screen interface instead of a switch. And again, you can have 16 of these daisy chained together. Now, I should also mention that the long range 16, and this is one of them here, this is the version 2, and this is the version 1. These are effectively four long range receivers bundled together in one box. So you can even see it says receiver A, B, C, D. This is a 4, 4, 4, and 4. So this does use 4 addresses across all of these outputs. So you could daisy chain 4 of the 16s on a single line. Again, within the context of how many pixels you can drive. All right, now it's also important to note that we can, under the long range system, for HinksPix, also do AC. This is an AC board, and what we have is the ability to control up to 16 outputs. Maybe I should flip that around here. And this allows us to control AC lights. This is the only receiver available on the market that does this. And you can integrate it right in line with any of your other regular long-range components. So this allows you to control legacy AC lights at 120 volts. Same arrangement, line in, line out, and at the top we do have, of course, a switch, just like the others. All right. Now, smart receivers also have some extra indicators. I mentioned this earlier because each receiver can be programmed as to a specific output. Just to aid in troubleshooting, it will tell you if you have a particular output configured. So there are some additional LEDs next to this type of board here that tell you that it is configured. Now, here in this model, you can see that it says no config. And it says A, B, C, D, that's the 4 receivers, and we can then configure them and we would see if they are individually configured. So there are some additional troubleshooting on there. Now they also all have test modes built in, so there's a button up there, there's also a button on this receiver, and then there's a button interface here. That is unique to the long-range smart receivers. All right, so one other unique thing you can do, you can technically integrate long-range smart and long-range regular, but because, of course, you only have one input right here, you would have to daisy chain from your controller to here, to here, then come out here, and then go to the long-range regular. So that means you can only put one long-range regular at the end of a daisy chain of smart. But it is possible to do, showing you the flexibility of the long-range system from HolidayCoro. So please see our other videos if you have very specific information on each of these model boards. They also have videos on how to configure these to work with common applications, or how to use the HolidayCoro HinksPix configuration tool that is built into the controllers for configuration of long-range smart receivers. If you ever have any additional questions, always feel free to reach out to us at holidaycoro.com/contact us.